Now, let us see what would be the distance from a given point to the straight line in the general form ax plus by plus c is equal to 0. Suppose if you know one point anywhere on the xy plane p x1 by 1, some point p x1 by 1, this point p is how much distance from the given straight line, where the equation of the straight line is ax, general form, ax plus by plus c is equal to 0. What does this mean? Let us try to work it out graphically so that we can have a better understanding. Right. Now, I just try to write a diagram here in this corner so that I can minimize the, say, this is the ax plus by plus c is equal to 0, is capital A, right? Then I have a point here, right? Its point coordinates are known, it's given, x1, y1 is given, right? So this is the straight line. If I know the coordinates of p x1, y1, and equation of the straight line is also known, that is a, b, c values are also known, then what is the distance between from this point to this straight line? Generally, from a point to the shortest distance only is taken from a point to the straight line. The shortest distance is nothing but the normal form, which is a perpendicular distance. So this distance, let us call it as d. Now our objective is to find out what is the value of this d, right? In terms of given known parameters. Known parameters are, we know the equation of this line and we know the coordinates of this point P, from which we are going to draw a perpendicular and what is the distance between this point to this straight line. Fine. Now what I will do is, I just join the points where exactly this is meeting the x-axis, right? And I'll join this point with the y-axis so that I'll call this as Ax. I'll call this point as A, I'll call this as B, I'll call this as C. Okay? Now, if I would like to, my total objective is to derive the distance from this point to this point, a perpendicular distance, normal distance. So it's perpendicular. So, if we calculate, we have to always see in terms of how can I derive the distance from P to this particular point C, where this distance D, how can I derive from the given parameters. The given parameters are x1, y1 is given, and we know the equation of this line. Now consider if this line is intersecting x-axis at A and y-axis at B, then from the origin OA is going to be x-intercept and OB is going to be the y-intercept. From the given equation, we can easily know what is the intercept of, what is this distance. This is the intercept value on x-axis, intercept value on y-axis. If we convert this into the form of x by a, y by b is that like that, see ax plus b by y plus c is equal to 0. If I divide this is equal to ax plus by minus is equal to minus c, right? X by minus c by a plus y by minus c by b is equal to 1. Can I write like this? Because minus c I am dividing either side, so minus c will come in denominator. But a I want to write it down because x I want to keep it, get it in the form of x by a plus y by b is equal to 1. Then only I can get this intercept of OA and OB, right? So by x-intercept is going to be minus c by a, then the coordinates of this point is going to be minus c by a comma 0, because on x-axis y coordinate 0. Similarly, the point b coordinates are going to be ax, x by a plus y by b, that is minus c by b, but that is a y coordinate, so x coordinate is 0 minus c by b. I can write like this, right? Now we know three vertices of this particular triangle, right? And from one vertex, a perpendicular is drawn. So the area of this triangle, why I am doing all these things is, I want to involve this d also and try to derive that d in terms of known parameters like coordinates of p and equation of straight line. So my objective is to get this value of PC. PC is equal to D, right? I'll write clearly here. See. PC is equal to D. So my objective is to get this. But I want to involve that in any given parameters where we know the values of this. Now, if you calculate, just think it over. Area of APB. We have one formula called half of base into height. Right? In this triangle, this is the height, perpendicular distance, and this is the base. So this is nothing but half of base is AB into H is D. Right? Now, can we get area of ABB? Because we know all the three vertices. We know the value of the formula for which we know area of the triangle which we have studied in the 10th standard. What is the value? That is area of APB is equal to half of modulus of. Let us start with x1, right? We have to go this direction or we have to go this direction. Let us go in this direction, right? x1 into y2 minus y3. Y value here is 0 minus y3. Y3 is minus c by b. Minus of minus c by b is plus c by b. Plus x2. We have done first this, then we will do x2. x2 is nothing but minus c by a. So plus will become minus c by a into y3 minus y1. That is, y is minus c by b minus y1. Okay, now you don't get confused with this here. Right. Then third one is x3 into y1 minus y2. But x3 is 0. 0 into anything is going to be 0. 0 into y1 minus v0, we need that, right? So I'll terminate it here itself. Now, this is equal to half of modulus of x1 into 0 is 0 plus x1 into c by b is c by b x1 minus of minus plus c square by ab. Right? Minus of minus plus again c by a into y. Right? This is the area I have got. Right? Now, in this, if I take a LCM here, AB, then B anyway there, so AC x1 minus c square plus c anyway it is there, c by a, so a is there, so BC y. Now if I take c is common factor here and AB also at the denominator, so 1 by 2 c by AB into C has gone AX1, right, minus C square. C only we have taken, so we will have minus C plus only by is left. By1. Okay, y is somewhere we have not taken the one. Okay, because it is a known factor. By1 divided by, nothing is there because already taken, we have taken the common factor here, right? Okay, this I can very well say that half of C by AB into AX1 mod of AX1 plus BY1 minus C plus 1. I can write like this, right? So I will keep this somewhere else because we have shortage of this display board. So area, I will keep it somewhere here like this. This area is 1 by 2 C by AB. We can take, let us take modulus also for this, plus and minus. And here AX1 plus BY1 minus C, right? This is the area of APB, right? Now, but our formula is this is equal to half of AB into D. Our objective is to get the D. Now we have to get AB also. AB also we can get very easily, right? Because we know both the coordinates. So AB is equal to distance between these 2 points, where 2 points are coordinates are known. That is square root of y2. Y2 is 0 minus y1. That is 0 plus C by B is square. So C square by B square plus minus C by A minus 0. So minus C by A whole square is nothing but plus C square by A square. Right? AB is equal to C square by B square plus C square by A square. So this is nothing but square root of C square by A square B square. This is nothing but plus or minus C by AB. Right? So this also we have got, that is AB value. AB means this distance between these two, that is base. Base, this is the area, base B is equal to how much? C by AB, mod C by AB. Right? Now, I analyze this. Now, as per our formula, half BH, right? Area is equal to half base into height, that is B into H. H is nothing but our D. So, what will happen? This area, D is equal to 2 into area of APB, right? Divided by base. So we know the base, we know the area of, so D is equal to 2 into, value is this for the area of ABC, right? 1 by 2 C by AB modulus AX1 plus B by 1 minus C divided by base. What is the base value? C by AB modulus. So this 2 will get cancelled, this will get cancelled, right? So that's D is equal to somewhere on the basic somewhere here. Yes. Somewhere we did a mistake here. Where is that? In calculating this, this is square root of a square by b square. So a square b square is a common factor. Right. Here we did a mistake, boss. No one pointed out. We take a square b square is a square b square is common factor. Then it is going to be a square c square. Then b square c square. So I can say c square into a square plus b square. Right? So ab is equal to square root, that is c into square root of a square plus b square. This comes under value of this one, right? Into AB value is right C by AB, correct, into square root of a square plus b square. Now d is equal to, this mistake what we have done is this LCM we are not taking properly, simple mistakes we did. So d is equal to modulus of ax1 plus by1 minus c divided by square root of a square plus b square. This is the value of the point P with coordinates x1, y1, and equation of the line is ax plus by plus c is equal to 0. Then the perpendicular distance from P to this line is going to be ax1 plus by1. Simply you have to substitute x1 and y1 values in the equation divided by x coefficients whole square, square root of x coefficient square plus y coefficient square. If you remember this is sufficient to understand, to derive the distance between a point from a straight line with the point coordinates are known and the equation of the straight line is known. Okay? Now, on the same lines, if you want to calculate distance between two parallel lines, you know only distance between two parallel lines. Say this is a line, this is a line. Say this is equal to y is equal to mx plus c in the point slope form, mx plus c1. This is y is equal to m1x, m2x plus c2. But we know these two are parallel. When these two are parallel and slopes are equal means m1 is equal to m2. So I can write simply this as m. Right? Because m1 is equal to m2, because they are these two L1, L2 are parallel to each other, L1 being parallel to each other, L2, then I can write y is equal to mx plus c1, y is equal to mx plus c2. Right. Now, you know this, then what would be the distance between these 2 points? In this case, what we can do is, distance between 2 parallel lines means, you take some point on this line, this cannot be the distance, this cannot be, all are distances, but distance means it is the shortest distance. Shortest distance is nothing but the perpendicular distance. Right? It is the perpendicular distance. So, you know very well that here, this equation is nothing but from a point to the other line, where you know the equation of the other line. But you need to know at least one point on this line, then only you will be able to derive, right? From that point you draw a perpendicular to the second line, and from this we can understand. So for that purpose, we will try to get one equation, any line which is non-vertical is going to intersect the x-axis and y-axis somewhere, right? Let us work it out only with the x-axis, because we know one point is sufficient. Say this is the point. This is the straight line which is intersecting, say, somewhere here. Here, x value is going to be negative side, right? X value will be negative. And what else we know? We know the equation of this. This is equal to, y is equal to mx plus c1. There is another line, y is equal to mx plus c2, right? Let us take one particular this point which is intersecting x-axis on the negative side. So x coordinate is going to be negative, right? And y coordinate is going to be 0 anyway on this, right? This is the value of x coordinate, so it is nothing but the intercept on x negative axis, right? So this one, if I try to work out in these lines, this is the line y is equal to mx plus c1. If I write it in terms of the slope is m, right? Slope is m here. So if I write this in the form of point slope form, right? So this is nothing but ax plus b general form, mx minus y plus c1 is equal to 0, right? So what is this? If we write it in terms of y is equal to mx plus c form, this is the form, right? Okay, now if we write it in the intercept form, same thing, intercept form, then what will happen? Mx minus y is equal to minus c1, right? X divided by minus c1 by m minus y by minus c1 is equal to 1. Isn't it? So this will become plus. Anyway, we are only bothered about only this value because I want to know x intercept only. So minus c1 by m, right? 0. Right? From here, I draw a perpendicular to this point. So this is the line where I have the equation y is equal to mx plus 2 plus mx plus c2. And here it is, the point is minus c1 by m and 0. From this point, I exactly substitute the values here in this equation. I'll get this value, right? So this value is equal to, I have it has to be in the same form. So y is equal to mx plus c2. I write it as mx minus y plus c2, right? So if I write like this, mx, so it will become, I substitute the value of x and y here, m, right, into x1. x1 is minus c1 by m. Next, minus y value is 0, so here this is 0, plus c2 divided by square root of a square plus b square, right? A is, what is A? A value is minus c1 by m, right? No, A value is in this form, so A value is going to be m. Square root of a square. A square means m square plus b square. Anyway, b what is the value of b? Minus 1. Minus 1 square is 1 because minus 1 is coefficient of y. Here ax plus by plus c. Similarly here mx minus y. So y coefficient is minus 1. So b is equal to minus 1. Minus 1 square is 1. Right? If we, the m will get cancelled. This is nothing but c2 minus c1. Or you can write modulus b is there. You can write c1 minus c2 also square root of 1 plus m square. That is c1 minus c2 by root of 1 plus m square is going to be the equation, distance from distance between two parallel lines where you know one point on the one straight line, one line, because we know the equation of both the things is easy, and then this m is nothing but the slope of both, because they are parallel, slope of both is m, there is nothing but c1 minus c2 divided by root of 1 plus m square. This is the distance between two parallel lines. Okay, I hope it is clear.